33. Let f be the function given by f of x is equal to 3 to the 5x squared. For what value of x is the slope of the tangent to the graph equal to 2? Okay, so the idea here, I need to first take this function. I'm going to try to find where its tangent line has a slope of 2. So I need to find the derivative of this function. So we'll start off with f of x equal to 3 to the 5x squared. And I'm going to take this derivative and take the derivative of this side. Now I'm going to write it using this notation because I'm going to have to do a little chain rule because I notice that I have 3 to an exponent, and then that exponent is another function, an outside function and an inside function. And the first rule I'm going to use, we should remember that the derivative with respect to x of any exponential function with a base, and especially important when it's not e, will be that base to the x multiplied by the natural log of that base. And that's the rule we're going to use here. I'm going to have to then use chain rule, but let's use that to begin and say, okay, so I have 3 to the 5x squared multiplied by the derivative with respect to x of 5x squared, my inside function. And the derivative of 5x squared, almost forgot something here. Let me get rid of this. Messed up my rule. The natural log of a is in there, so the natural log of 3 times the derivative with respect to x of 5x squared. Alright, on with things. The derivative of 5x squared, we bring down the 2, multiply it to the 5, so we get 10x here, so that's going to become 3 to the 5x squared multiplied by the natural log of 3 multiplied by 10x. And I like cleaning this up a little bit, making it a little nicer. I like having these sort of coefficients, 10 and this x, out in the front. So I'm just going to write like that, 10x times 3 to the 5x squared multiplied by the natural log of 3. And now I want to find where it's equal to 2. So I want to find where f prime of x is equal to 2. And what I can do is say, okay, I know f prime of x is 10x times 3 to the 5x squared times the natural log of 3. So I'll bring that in for this f prime of x. So 10x times 3 to the 5x squared multiplied by the natural log of 3 is equal to 2. Hey, okay, we have an equation to solve. And this equation is really kind of tricky. But that's not a problem, because remember, we're in the calculator section, and I have numerical solutions, numerical approximations here. I don't have an exact answer on here. And whenever I want to solve an equation numerically, I can oftentimes just look at the left-hand side and graph this. Look at the right-hand side and graph that as a different function. And my goal is to find the x, so I want to find what x value will make this left-hand side y1 equal the right-hand side y2. That's what my goal is, and I can do that with intersecting these two graphs. And we'll look for the x value. So let's bring that up, bring up our calculator, turn it on. Okay, so I want to graph this function 10x multiplied by 3 to the 5x squared, close that off, multiplied by the natural log of 3, close that off, to make sure we got 10x, 3 to the 5x squared, times the natural log of 3, okay, good. And the y2 is just the constant function 2. And let's graph these. There's the first curve, this really ugly mess. There's the second curve, the line there. And so basically I'm trying to find where both of these intersect. I'm going to see it's really close to 0. No surprise there, all of my choices are either 0 or close to 0. So to find the intersection, I'll do second calc. I'm going to go down to intersect, so I'm going to press 5. Let's get close to it. Alright, I'm on my first curve is y1. I want to use y1. My second curve is y2. And my guess, well, I'm really close to where they're intersecting, so that's where I want to guess. And I see that I intersect at 0.158564212. I'm looking for the x value that makes this happen, so that's approximately 0.159. That means that my answer choice is D.